Coming back to analytical and logical thinking, it doesn't come both the thing, be it analytical or logical, it doesn't come naturally. So more and more you discuss with your colleagues, or you refer the papers, you see the videos, or you practice yourself. So example here, I'm just trying to picturize two things. To decide between the algorithms, or to decide between the methods, you need to refer multiple papers to understand which you should be knowing the pro and cons of individual papers and the algorithms. Only then you can choose the best method or best algorithm. So that's through purely on the publication side, right? Or if you're working with a bigger team, it's always if you raise a topic on I would like to go for this, there are this many options are available, A, B, C, D, which is the best option to go with. You can put the question on the table so that you can see what your colleagues are saying. So it's kind of a brainstorming method, which is a good one, right? So finally, if you are going to tell anything, be it a diagnostic or be it a research module, without validating anything, you can't say. So what does that means? If you read a paper and you want to do some task and you want to do similar kind of study, first to replicate those kind of, get the data from them, replicate in your environment the same kind of thing, get an understanding, and then you touch the new data, so that whatever you are going to say from these findings are relevant and reliable, right? So the validation is very much important. In fact, diagnostic, it is compulsory. We can't even ignore, or we can't, the first step of the total if you want to say I'm going to launch a test, the first question will be asked is how many samples you utilize for the validation. So that's kind of an important key role. When it comes research, it is compulsory, right? So there is something called best practice guidelines, which is there in the not only in the clinical, it is meant for anybody. What is meant by best practice guidelines? So there are board members or the icons or the legends in the same field who already have did the practice, and they already come up with the standards or normalized, right? So those details they have put up for public, they have put up for public, so that they don't want to reiterate the whole validation process and come to the standardization. So it means they did all the homework and they have told very clearly. So there are 15 steps as an example. This is a GATK, which I would like to highlight as an example. Or GitHub is one of the important places where all the informatics tools are available, where you can download, install, and use it. So these places very clearly, they will be giving a note saying that step 1, this is what you need to do. Step 2, this is what you need to do. Step 3, step 4, step 5. So this is like this. This basically helps us to cut short the time to do our experiment, because it's already been validated, right? So I would like to highlight two of it here very clearly. GATK, which is one of the things which is widely used, as well as the GitHub. GitHub is basically a portal for the developers, right? So in that case, you will find some people who are developing and posting there, and the other side you will be seeing some people who are utilizing it on daily basis, right? So GitHub is basically a place where you can get all different kind of softwares over there. Coming back to policies and compliances. So when I say policies and compliances, pretty much the best guidelines and policies are very much similar, but the only difference is best practice basically kind of very frequently changing, right? Because that is kind of a open source. But when it comes policies like, imagine it's like a corporate rules, right? So there will be an improvement obviously, but again, it's a kind of board members are involved, and certain people who are in the subject matter legends will be involved in this, and those people will be deciding the rules and regulations for the current generation as well as the future generation, right? That's what the policy is. So that will be revised very commonly, right? And it has to be followed very strictly. Otherwise, when there is an audit, example, what do you mean by audit here? All the diagnostic labs of the hospitals will be going for a audit by a board or the committee, external committee, where they'll be checking whether they are following all the steps properly or not, right? So those kind of things will be defined in the policies very clearly. Again, compliances are pretty much same. It has been defined already. You have to do A, B, C, D. So if you are not doing C and A, B, and D, if you're going, obviously you will be asked in future why did you skip this step C. So these are all the things which are very much important when it comes to the clinical first hand, and in research, if you try to follow it is well and good, right? For example, I just want to give an example as far as bioinformatics concerned in the clinical field, right? When you try to say the given mutation is pathogenic, it's not like just because the database is saying, just because the paper is saying. We are not only taking care of literature survey base or probably the database. Rather, we do a math also. What does that mean? It means based on this. This is basically nothing but the ACMG guidelines which came out on the on how do we classify the given variant as pathogenic or benign, right? Based on the these are all the if you see the black ones which is over here, black colors are criterias, and this is very clearly benign, strong, supporting, and this is pathogenic, strong, moderate, strong, weak. So what does that means? If these are all the qualities, or probably if these are all the parameters, this has been met, this particular variant is met, and we can go for a certain classification. So this is what I meant as policies or compliances, which is basically very much important to capture when before you report, right? Particularly, this is from ACMG, which is widely followed by for this is for germline specifically. There are different criteria for somatic as well, right? So current last topic which we are in, there is something called data flow as well as archival method. This is kind of busy slide, and this is kind of for advanced users, I would say. So for let me go back a little bit to give an explanation on biologist doing bioinformatics, right? So as a starter, if you know biology very strong, but you want to know the informatics part, right? It is better to use Galaxy kind of open source tool, which is cloud environment, right? The things are already placed there. You need to call them, right? You need to call them and you need to give the file. You need to upload the file, whichever you have, and it does the analysis and it gives, right? Once you have an understanding on it, then you can go. The easiest tool or basic tool to get to learners are based scripting, are based pipelines, right? And then Perl, Python, and then, so these are all. This is how the step by step you can establish. Mainly, where does the what do I suggest is if you want to go for a as a starter, you want to go for, you can go with R as a starter. How does the R package can be downloaded? There is something called R Studio, which you can download and install in your Windows PC, probably in your Linux also, even in the Mac also, right? So there are different kind of tools are there for different functions. So to do specific tasks, you need to have different library. Basically, you need to download. You can check by default, does it have these libraries in place? If it is not having, then you can download them and install them. Once it's installed, by just giving basic commands, it will work. This is R. The same way, if you want to go for the, like say, I want to learn the Linux or I want to learn the scripting, the first thing which I would suggest is try to go for a shell script, awk script. There are bash scripts. So why I'm saying these are all mostly single lines, right? Perl Python comes next. So before even that, if you can go for it, the first option I would suggest is very strongly, you can go for R package to learn, right? Because it's easy to learn, right? And the second one is I would say awk, shell, and bash. That is easy to learn because it's single liners mostly. Liners you can learn. What do you mean by liners? You don't want to write a 100-line scripts, rather it is single line, 2 line, 3 line, those kind of scripts. That will give you. So why do you need scripting? Suppose if I have 1-2 files to process, I can do by manual methods. But if I have 100 files of same kind of, like say I have sequenced it, I have a data ready, already the file sizes are big, and I can't process multiple files at a time. So in that case, I need to probably automate them. That's what my title says very clearly, as you can see, automation, right? So you need to automate all the files at one go. So you need to write a small loop. It might be while loop, like for loop. It's your own interest, obviously. And the scripting is also either Perl or Python. But as a starter, I would say go for R, and then awk, and then bash, and then shell, right? And then comes Perl Python. And if you feel no, these are all things I know very well, tell me something new. Then comes Docker and Nextflow, and there are many more cloud-based software integration tools are available. So reason for saying this is, if based on your level of knowledge to handle the data set or to handle the analysis part, you can choose a different kind of scripting languages. So that's a basically current need. So these are all the brand logos which I have put up. as you can see, R has a bioconductor module which will be helpful for many of the functionality. Nextflow is basically for automation. GitHub, which I told before, basically most of the developers will be putting up in GitHub that can be used in future. And Docker, you can build you can write scripts on top of it, and that can be deployed in the Docker. And then you have a Google Cloud and AWS. I guess there are some limited space they are giving for free to develop some softwares also if you're interested in. So in that case, starting from taking the data to the development, every level there are free software. Most of the things are open sources when we speak about NGS or probably even the snip arrays or microarrays, right? So in that case, it's just that we need to prepare our mind to collect the things together and to work on the problem.